We've been dealing with binomials ever since you were aware that you were dealing with binomials, right? Binomials are basically two terms, two monomials, right? Either subtracted or added to each other. And we deal with, we've always done, let's say, if you have a binomial a plus b, this we do all the time, right? And everybody knows that this is what? A squared plus what? Really? Right. Okay. And then in algebra 2, we tell you this one, okay? And we give you the formula and we say to memorize it, but I know nobody ever does, okay? So in math, higher level math, and in physics, this happens a lot. We have binomials very, very often, very commonly, and often we have to raise them to a certain power. Usually it's to the power of n. And then we have to think, okay, what is going to happen to this if n is small, if n is large, if n is infinity, and so on and so forth, right? For that, the binomial expansion comes in, or the binomial theorem, okay? So the terminology I need you to know here is, we already know what a binomial is, okay? And what an expansion is. So an expansion of binomials is when you raise it to a power, the terms that you get, right? Basically like the expanded form that you get. So the term binomial expansion is it comes up very frequently. All right, we're gonna do the first few here, and we're gonna see if there are any patterns. So basically what you have here is a plus b to the 0, and then up to a plus b to the 5, okay? And somebody sat there and they multiplied these out. So for example, a plus b to the 0, that's whatever, it's just to the 0, it's just 1, right? And then a plus b to the 1, we know it's just a plus b. To the 2, we know how to do that one. 3, and then somebody sat there and and they wrote out what happens if you do a plus b to the 4, a plus b to the 5. So this is pretty much what you get, right? And the stuff on the right is the expansion of all of these here. There are several important patterns that come up here. Okay, the first is number of terms. So first let's define what n is. N is the exponent, right? So first let's talk about the number of terms in the expansion. How does that relate to n? When n equals 0 here, we have 1 term. When n equals 2, we have 3 terms. When n equals 4, I have how many terms? 5. So how many terms? N plus 1, right? Each expansion is going to have n plus 1 terms. All right? Okay. Let's take a look at the first and the last term always. So look at this one. The first term, when you simplify it, it's a to the 1. The last term, b to the 1. Here, a to the 3, b to the 3. The very last one, what do you get? A to the 5, b to the 5. So the first and the last are always the first term to n, the second term to n, right? So that's what the first and last terms are, always a to the n, b to the n. Okay, let's take a look at each of the exponents, each term. So let's take this one here. Okay? Look at the first term and look at the exponents. 3 and 0, they add up to 3, 2 and 1, 3, 1 and 2, 0 and 3. So in each term, the sum of the exponents is always n. Okay? Okay, let's talk about individual powers. Okay, let's take, this one this time. And let's look at the first term and the exponents of the first term, a. Look at this one. This is a to plus b to the 4. So n is equal to 4. So it's a to the 4, 3, 2, 1, 0. And then b to the 0, 1, 2, 3, 4. So do you see that? The powers of a decrease from n, and the powers of b increase to n. And what about the coefficients, right? Take a look at the coefficients. In each case, so if you split each of these down the middle, right? Look at the coefficients there, the red ones, 1 and 1. Down the middle, you have 2, 1, 1 as you expand out. Here, 3, 3, 1, 1, right? You see how symmetric it all is? You have a 6 in the middle, 4s, and then 1s, okay? So, so many patterns here. All right. Let's just focus on the coefficients for now. Yeah.
Sorry, when it says the power, the sum of exponents is n.
In each term, let's say I just like randomly pick that term, right? You have an exponent of 1 plus 2, 3. Okay, so let's focus on the coefficients. The binomial coefficients, those are those red ones over here, right? This one, this one, this one, and so on, right? Okay, how do we come up with them? Well, we all know about Precalc, right? Where have you seen Precalc, or when have you heard of Precalc? Chemistry. When do you use it in chemistry? What is it the unit of? It's the unit of pressure, right?
Yeah.
Force over area, Newton per meter, Pascal, kilopascals. That's 1,000 Pascal. Okay. Well, he didn't only work with pressure. All right. Here we have his triangle. So the coefficients that we're talking about, those red ones, they're called binomial coefficients. And we can arrange them in triangular form like this. The way it works is you start with a 1 and then a 1, 1. Like what? What does that remind you of? Almost. It's almost like the Fibonacci, right?
What?
Fibonacci series? My, it has been a long break. Okay. So then the next one, we start with a 1, and then the next one over is going to be the sum of the two numbers directly above it. So 2, and then another 1. And then here we have 1 here, the sum of the ones right above it, the sum of the ones right above it, and then a 1. All right? And like this, it continues. So you always have a 1 and a 1, and then sum, 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 sum. So let's do the next row here after 1, 6, 15. I have a 1, then what? Then 7, 35, right? And then a 1. So you see the symmetry, right? And obviously because it's, odd numbers, even numbers, in the one case you have the middle number appears once, and then the middle number appears twice, and once, and twice, and once, and twice. Okay? Now, when we're doing the binomial expansion, these correspond to our n's. The very first one corresponds to n equals 0, then n equals 1, then n equals 2, and so on. And that's very clear, right? Because if n equals 2, then we're doing a plus b squared. And what is a plus b squared? 1a squared plus 2ab plus 1b squared. Okay? Fabulous. So that's where we get our coefficients. So with that now, let's use Pascal's triangle to expand each of these, right? So here I have 3x plus 2 to the power of 5, right? That means I'm going to go 6 steps, right? Because I'm starting from 0. So this is n equals 0, 1, 2, 3, 4, and 5, right? Okay, so here's what we're going to do. In each case, I'm going to have those, so for this one, I'm going to have those coefficients, 1, 5, 10, 10, 5, 1. So it's going to be 1, 5, I'm going to go in increments here, right? Like little modules, the first time. And then afterwards, we're just going to do it all together. Okay, now, this 3x is my a, right? So remember how the exponents of a goes, it starts with n, goes down to 0. So here I'm going to get 3x to the 5, 4, 3, 2, 1, 0. And then this is my b. So 2 to the 0, 1, 2, 3, 4, 5. And if you just want to check very, very quickly, if you pick any of the terms, right, the exponents always add up to what? Right, 5. I heard you. Okay? All right, and then now after this, it's just mundane math. All right, we just have to do the math. So 3 to the 5, that's 243. X to the 5. 5. And then plus 5 times 81 times 2, x to the 4, plus 10 times 27 times 4, x cubed, plus 10 times 9 times 8, x squared, plus 5 times 3 times 16, x, plus 2 to the 5, 32. Okay? And then at the end of the day, we need to simplify further. 243x to the 5, 810x to the 4, 1080x cubed, 720x squared, and 240x, and 32. Okay? Yes? Yes. And then, you know, obviously, like, so this one, I went very, very slowly. Lots and lots of steps. Okay? But you don't have to do them in, like, you know, like, with, like, as this, like, in components like I did this one. So let's do the next one, not necessarily quickly, but more swiftly. Okay, like more efficiently. All right, so the next one is x minus 2y to the power of 6. In my triangle here, I go up to n equals 5. So one more step will give me 6. Right? Okay, so again, this is A. Now this time B is negative 2y, and that's the difference here, right? Is that your B is negative, not positive. So keep that in mind. All right, let's go here. My first coefficient is 1. Then I go x to the 6, negative 2y to the 0. Right? Remember, your exponents must add up to 6. Then plus, the next coefficient is 6, x to the 5, negative 2y to the 1. Then 15. X to the 4, negative 2y squared. 20. X cubed, negative 2y cubed. And then what's the next coefficient? 15. X to the 2, negative 2y to the 4. 6. X to the 1, negative 2y to the 5, and then 1x to the 0, negative 2y to the 6. All right? So we're copying the coefficients from the triangle, and then if you just count down the exponent for A, you compensate the exponent for B in order to make sure that they all add up to the n. All right, and then again, it's just mundane math, right? So this is going to be, oh, well, it's not so mundane. What's going to happen to the sign of the terms now? They're going to, what's another word for change? What are they going to do? What's another word? Starts with an A. Alternate. It's going to alternate. Because in each case, well, in each case, look, you have negative to the power of 0, which is just a positive 1. And then you have negative to an odd exponent, negative to an even exponent, odd, even, odd, even, odd, even, right? Anytime you have a negative number with, you know, that's alternating between even and odd and exponent, you're going to have alternating sign. So that's cool, right? So then Here we're going to get x to the 6 minus 12x to the 5y plus 60x to the 4y squared minus 160x cubed y cubed plus 240x squared y to the 4 minus 192xy to the 5th plus 64 y to the 6th. Okay? This is all nice and fine and cute.
Wouldn't it be plus 30 x4 y squared?
It's 15 times 4 because it's 2 squared.
Oh. Yeah.
All right. So, Pascal's triangle is fine and cute, right? But if I had to do x minus 2y to the power of 57, okay? And all I needed really was like the 31st term. Pascal's triangle, not so cute anymore, okay? That's where the binomial theorem comes from. Okay, everybody's favorite theorem, binomial theorem. All right, so for this, a little bit of background. You guys remember this? What is that? I'm not just excited about a 3. What is that? Huh? It's used in probability. What's that exclamation? But what's that exclamation called? A factorial. Remember 3 factorial? And you know exactly what it is. It's 3 times 2 times 1, right? We use it in probability. That's where we used it last in geometry when we were doing probabilities. Okay? So that's a factorial. And you learn about factorials back in middle school. You use them in geometry when we do combinations and stuff. What's 0 factorial? Again, I'm not excited about a 0. It's a 1. It's a 1. And we'll have time this year to prove this one. I always want to prove it, but we have time this year to do it. Okay, now let's go backwards a little bit, okay? And we've been looking at the exponent for the a term, right? But let's look at the exponent for the y term. Let's say we call the exponent for the b term r, right? So if the exponent to the b term is always r, here, if the exponent to the b term is r, can we come up with an expression for the exponent of the a term? So in other words, what I'm saying is, suppose this is r, okay? And in this case, n is equal to 3, right? What's this? How do I come up with that? It's r. N minus r, right? Here, if r is equal to 2, this is n minus 3 minus 2. If r is equal to 1, this is 3 minus 2. So here, if r is equal to 1 and n is 4, that's n minus r, right? So another way we can write those exponents is a to the power of n minus r and b to the power of r, right? So that's another way we could write those exponents. And in fact, lo and behold, that's how we write the exponents here, right? So, so if you look here, the binomial coefficient of the a n minus r b to the r term, okay, is this. So this is how we can come up with the individual coefficients. It's either Pascal or this. So the 1, 6, 15, 20, right? We could either do it with using the triangle or this. Okay. This is what we learned back in geometry. It was the combinations, right? If you have a sock drawer, you know, with, if you have like, whatever, 20 socks in a drawer, red and green and whatever, how many different combinations of 2s can you come up with? You remember? That's how we did it. So what is this? How do you do it? It's n factorial n in this case is our exponent, right? It's n factorial over n minus r factorial, r factorial. Look at this, n minus r factorial, r factorial. Oh my God, how cute. Like it all fits in like a neat little box, okay? So then that's how we generate our coefficients, okay? All right, so take a look at this one, a plus b cubed. We're going to do it manually. Well, what does Pascal's triangle say we're going to get for our triangle, for our coefficients for the cubed? It's 1, 3, 3, 1, right? It says the coefficients are going to be 1, 3, 3, 1. Well, let's see. All right, we're going to do it manually using the binomial theorem. A plus b cubed. This is going to be c. This is n, and this is r. Which one of those is going to change? The n or the r? The r, right? Because n is just n. It's given to you. And then it's going to be a cubed b to the 0 plus c 3 1 a squared b to the 1 c 3 2 a b squared c 3 3 a b cubed. So now that we've done this, all right, we know that n is the exponent, and we know that, yeah, a to the 0, right. And we know that r runs from 0 to n. Okay? Okay, so let's see what else we're going to do here. All right, here's what we're going to do here. So, okay, let's do this. We're doing it manually all the way. So here it's going to be n factorial, so that's the first one, over n minus r, so the difference of the two, times the second. Okay? And then it's just a cubed. Plus, that's the formula. Yeah. So then again, it's n factorial, the difference of the two, and then the second one, r factorial. And it's a squared b. So the next one is going to be 3 factorial over how many? 1 factorial, 2 factorial, ab squared. And then it's 3 factorial over 0 factorial, 3 factorial, b cubed. Okay, now for some cool math. What's 3 factorial? That's 6. And this is 6 and times 1. So all that goes away as 1. Right? So that's just a cubed. Plus. Okay, now look. Here I have 3 times 2 times 1. And here I have 2 times 1. Remember how we did this? Everything that they have in common goes away. So I just have the stuff that's not in common. So 3. A squared b plus, same thing here, right? 3 times 2 times 1 over 2 times 1. So that's just a 3. Plus, what's that? 3 factorial over 3 factorial. That's just a 1. What did we get for the coefficients, guys? 1, 3, 3, 1. Isn't that what we needed? 1, 3, 3, 1. Right? Cool. Okay, so everybody's favorite phrase, you can do this with a calculator. I guess it's more of a sentence than a phrase. All right? So, using a calculator, all right, so suppose I'm going to do C31, okay? You put in n, which is 3. And then you go into, I'll give you a minute to check out your calculator. All right, so we did 3, and then we're going to go math into the probability tab. You could either go left or right. I go shortest distance. You're going to select the third option. That's your combination. And then you're going to put in your R, which I guess I chose it to be 1. Enter 3. Really fast. Yes, you go math all the way down to probability. I go left because it's closer. And then number 3. PRB, probability. Huh? Yes. Now, to go for successive steps, right? Don't do the whole thing again. You know I hate that, right? We just do, not second answer, but second entry. I have a typo there. Whoops. I did it again. And then you just edit this one, right? You just go to 2. Okay? So here I have a typo. This should be second enter. Or you could just go and click on this one and then just edit, and it gives you a 1. Okay?
You would start at 0 and then go to 1.
Yeah. We're going to do 1 actually. All right. So in all reality, nobody really sits there and says, I mean, as fun as it would be, right? To do like, you know, a plus b to the power of 157 and, you know, let's do all the coefficients. Nobody really does, like, sits there and tries to expand all 158 terms like that. But sometimes it is important for us to know the coefficient of a specific term in that series. Okay? Notice how I called it a series? Where have we used that word before? Series. Sections 1, 2, and 3 of this chapter. Oh my. Okay. So, here's what we're going to do. We're going to find the coefficient of the indicated term in here. So look, I have a plus b to the power of 10. And I want the coefficient of the 4th term. So how many terms? It's a minus b. A minus b to the power of 10. How many terms? 11. 11 terms. I want just the coefficient of the 4th one. Okay, so it's not worth it for me to sit there and expand out all 11 terms if I just want the coefficient of 1/11 of it, right? So we're going to go directly to that one. That's where the binomial theorem is more powerful than Pascal's triangle, okay? You just go like directly there. Okay, so here's what we're going to do. If it's the 4th term, right, then I say r is equal to 4 minus 1, 3, right? Because r is the exponent. For the 4th term, it's 0, 1, 2, 3. And then how much is n? N is 10. Okay? So n minus r is equal to 7. All right? Okay. So now, this is the form. A, n minus r, b to the r, right? That's the form of it. So now let's put in everything we have. So it's c, 10, 3, a, 7, b cubed. Is that right? You see how it all fits? Like you have a 10 and a 3 on the bottom there, and then the 7 is the difference of them, and you know, like it's all so cute. Okay? So we're going to do this in the calculator. So we're going to go 10, math, probability, 3rd option, 3. Look at that. It's 120. How cute. So this is going to be 120, a to the 7, negative b cubed, right? Because it was a negative. So then it's negative 120, a to the 7, b cubed. Now here, okay, this is the actual 4th term. Because b is minus b. It's minus b, right? So this is the actual 4th term. Is this what I'm being asked for, though? What am I being asked for? Just the coefficient. Negative 120 is the coefficient. Okay, so the blue is technically the answer to this question, but that's the 4th term. Right? So had we done Pascal's triangle, we would have had to write like all 11 steps of it and then, you know, done it that way. And imagine if it wasn't 10, if it was like 57. That's not cool. All right, so here's another one. Coefficient of the, now it's asked differently, see? Now, okay, n is 8. We know that. That's cool. But now I'm not given which term, like by number. I'm told x to the 7 y term. So if A is 3x, right? Huh? Is it the second? So what's R? What's n minus R? That's this one, 7. And then what's R? R would be 1, right? So it's the term when R is equal to 1. So what I want is C 8, 1, 3x to the 7, and negative 4y to the 1. Okay. Now, when it asks you for the coefficient, it doesn't just want the binomial coefficient. It doesn't just want the coefficient from this combination. That's too simple. It wants the coefficient when it's all multiplied out, right? Okay, so what's that going to give you? 8, 1. So that's 8 factorial. When it's a 1, it's always easier. You don't even have to go on your calculator because it's 8 factorial over 7 factorial, 1 factorial, right? So it's just what? 8. Or you could put it in your calculator. And then it's 3 to the 7, negative 4, x to the 7, y. Now when we multiply all those out, negative 69,984 is your coefficient. Okay? All right, so let's go here. We're going to expand. We're going to do it semi-manually, okay? So this is C 5, 0. Using the binomial theorem, we have to do this, right? So we start with 5, and then R starts with 0. And then it's 2t to the 5, 3u to the 0. And then C5, 1, okay? 2t to the 4, 3u to the 1. C5, 2. 2t to the difference, 3. 3u to the power of r. Okay. C5, 3. 2t4, 3u. No, 2t2, 3u1, 3. Okay, now I'm back. C5, 4, 2t to the 1, 3u to the 4, and then you always run out of room for these. It's 2t to the 0, I'm not going to write that one, and then 3u to the 5, okay? Yeah? Cool, right? Okay. So, now, what to put in your calculator and what not. Advice to you, you know tests run long, okay? When it's the first one, 5, 0, you know from everywhere that first of all, it's going to be 5 factorial over 5 factorial, so that's going to be a 1. You know that Pascal's triangle is going to give you a 1 for the first one, so don't put that in your calculator. That's going to be a 1. And then it's 2 to the 5, 32 t to the 5. Plus, okay, if you want to put these in your calculator, fine, go ahead. Or if you want to do it manually, that's fine too. Or mentally, rather. 5 times 16 times 3, t to the 4, u, plus 10, right? If you put it in your calculator, times 8, times 9, t cubed u squared, plus 10. Okay, now look at where we are. We have 6 terms here, right? And right here, I'm at the middle. And you know this is going to be symmetric. So my binomial coefficients are going to repeat as 10, 5, and 1 here. Okay? So remember that. So here it's going to be 10 times 4 times 27 t squared u cubed. 5 times 2 times 3 to the 4 is 81, tu to the 4. And then 1 times 243, u to the 5. So we have 32t to the 5th, 240t to the 4, u, and then 720 t cubed u squared, and then 1080 t squared u cubed, 810, okay? Yeah. So each time you expand something, you get a sum, okay? And a sum of a sequence of numbers is a series. It's more fun when that series is adding up numbers that are not put together at random. Like, are these coefficients here by random? They're not, right? Each one of these coefficients was generated in the same methodical way, right? So how fantastic of a series can this turn into? In fact, it goes so well hand in hand in series with series that we could write the whole thing in sigma notation, okay? So I could either say, you know, a plus b, whatever, 2t plus 3u to the 5, or I could write the whole thing in sigma notation and use it as a series. Why not? The difference is, well, one little change is, when you're using sigma notation, instead of this notation, right, the world of series has its own notation, and we use this notation. So basically it's the same thing. You see how you have the n and the r appear in the c notation, in the combination. Well, we get rid of the c, and instead we put n and r in parentheses like that, and mentally those two mean the same thing to us, okay? They're interchangeable, sort of, okay? So let's represent this using sigma notation then, okay? 3x minus 5y to the power of 17. We're not going to expand this. We're just going to put it in sigma notation. Well, from here, can we figure out n? What's n?
17.
N is 17. Now, does that ever change? No. It doesn't change. And, you know, so I have n and r. Does r change? Yeah. R changes, and it goes from what to what? 0 to 17, right? So here, we're going to sum up all of the terms we can generate when r goes from 0 to 17, right? That's the big picture. Now, what's each individual term going to look like? Each individual term is going to have its coefficient, which we get with the binomial theorem, right? The combination 17 and r, right? That's the same as writing this. Okay? So that's the first part. And then what comes after? It's a to an exponent, b to an exponent. So it's a, in this case it's 3x. What's the exponent of the first term? N minus r, thank you. So it's, in this case, n is fixed, so it's 17 minus r. And then negative 5y to the power of r. You see how easy that was? Yeah? Isn't that cool? Let me write it closer. Okay? So that's that in sigma notation. Okay? And then what does that tell you? Like, this tells me now, if I have sigma, look at what this tells you. Sigma means add up all the terms from 0 to 17, a total of 18 terms. And then what's each term? Coefficient, 3x to the power, negative 5y to the power. And then the next one, coefficient, 3x to the power, bubble to the power. Isn't that cool? Right? Nice, concise little notation for us. Okay? That's fantastic. Okay, so that's binomial theorem for you. Now,